Hey, this is my assignment 1 for computer graphics module. I've made this planetary system using cubes. So in this system, there's a sun in the center and two cubes which are like planets to the sun and revolve around it. Each planet cube has two satellites which revolve around the planets. I use the parametric equation to give cubes elliptical paths. So there is a hierarchical transformation between cubes. Sun is the root of hierarchy for planets, and planets are the root of hierarchy for satellites. I use the keyboard functions to alter, so let's say the camera position, so like we can pan in, pan out, or we can also rotate the whole scene here. We can mess with the lightings too. So here also we can scale it down or whatever. So if I scale it down, it'll look like this. I can also stretch it out just like that. In the corner here we have top down view with the orthographic projection, and it gives the top view here. Now let's look at the code. So this is our main function here. We've called the display mode, given the window size, given the name planetary system, okay, and call the display function, the keyboard function here, and it's an infinite loop. So here these are the header files, all the header files. So I created this cube.h which contains the 36 vertex count. So these are the 36 vertex points, and the three vertex points combine together to form a triangle. So similarly there are 12 triangles. So for 12 triangles, these are the normals for 12 triangles. And in this simple vertex shader, we have this ni, we have defined this ni parameter, and we have given as an output this ni, and this output is used as an input here to give the fragments a color. I multiplied this vector with 100 to give a dominant red color to my cubes. So after header files, we have defined some global parameters. Some are for camera position, so to control the camera. Some are for the elliptical motion and all. So let's look at the display function here. So I given my background a black color, and we've defined this model view projection. So this is the root of hierarchy. So this is the we are defining the center cube here. I've I've transformed the central cube to have a better view. So I rotated it, scaled it, and translated it, and I used the lookat function, GLM lookat function, to alter the camera position. So the camera position can be controlled with the keyboard, and to give an elliptical path to the planets and satellites, I'm using this counter here. So this counts the angle from 0 to 360. If it go beyond 360, it go back to 0. It reset to 0. So the parametric equation for ellipse is x cos theta y sin theta. So for x1, we're defining the cos theta. This is the angle, and this is the radius what we have. So if we change this radius, the radius of the x parameter changes, and this is the radius for y parameter. This is y sine theta. So similarly, we use these parameters to translate our planet here, and So here we have defined the hierarchy. So global 2 is the planet and global 1 was our sun. So global 2, the planet is child now for the parent sun. And similarly we have defined the satellites, other planets also. Now let's look at the keyboard function. So I defined the, let's say this X is for the camera position, so it increments the camera position, decrements the camera position. This normalizes for the left and right. We can move forward, translate our scene forward, backward, or scale it down, stretch it out, rotate it. So all this is for the keyboard function. So that's it. The There is a link to the source code in the description below. Thank you for watching.